guys, what's up? So I doubt anyone's gonna be in here yet, for a very long while, but I'm just gonna, start explaining my math and what's going on. So, first up, here I am in OneNote by Microsoft, right? I have a little Wacom, or a little Wacom, whichever. And that's how I draw with this. So first up, what I'm going to be doing is I'm going to be combining X and Y, motion vectors, into polar coords. And there are a variety of reasons why this might be helpful, but this is essentially what I'm going to be doing. So actually I'm going to switch over to this. So first thing we're going to do, right, is we're going to start off with what are our motion vectors? So let's say M is a type of motion. That could be velocity, that could be acceleration, that could be whatever. So M is your type of motion in the nth dimension, and M is technically a function of t, but it also describes linear motion in one dimension, so we can just rewrite that as vector m of n, right? Because it's motion in the nth dimension. Now, each vector will be composed of its parts, let's say M, X, X, M, Y, Y, so on, up until the nth dimension. Now, all that is very messy looking, so I'm going to take it off screen and go into more depth. Or I guess less depth. Delete that, delete that. So we're going to start off with the position of X and Y. So here we have position of X, that's its own vector, right? And then position of Y. Pretty simple. Now the position of X is technically a function of t, which, again, is the integral of velocity and yeah. So we have our two position functions. We already integrated or differentiated or whichever was necessary to get to them. I guess, integrated. So we have them. What we're going to do is, now we're going to have this graph. I'm going to make it right about here. And we're going to set this to be X, this to be Y, and this to be T. Boom, perfect. So as something moves in these two dimensions, we're going to show it with depth, with how that works. So one problem is that with Y is we want to use e to the I theta. Now this is, an imaginary numbers type of thing, where we have 1, -1, I, -I, and we want to go around. So instead of having the y-axis, what we're going to do is actually switch over to the IY. So essentially anything on the I-axis is going to be anything on the y-axis. So P of y is now going to be I P of y. Perfect. So this point right here is z. Z is a complex number. There it is, z is a complex number, which means z can be rewritten as a plus bi, which is, a real part and an imaginary part. Or it can also be represented as r times e to the I theta. Now you may be wondering, what is this e to the I theta? What the fuck is he talking about? There's a very, very long, complex set of proofs that I have in my overleaf document that I'm not done with it. I have another one proving that the Pythagorean theorem is true, and proving that I to the I is a real number. And in that I've proved this using, differential equations. So this length is r, this length is the radius. The radius is the magnitude of z. Because here's z, this is how far away it is from 0. This is py, it's IPY right there, and that's p of x. So when something pushes it out that much and pushes it out that much, it's going to be about here. Pushed out and up. So now you may be wondering, how do we combine this into one function? So first thing we're going to need to do is understand what e to the I theta is. So e to the I theta is equal to cosine of theta plus I sine of theta. Cosine of theta plus I sine of theta. Now you may be wondering, what the hell does that mean? Let me explain it to you. Over here, we have a graph. We're going to call this, the complex plane. This is imaginary. This is negative imaginary. This is positive numbers, and this is negative numbers, right? So if we take a number what the fuck? Okay, there. If we take a number, this is its real part, right? This is its real part. And then here we have bi. So here it goes out a by this much. That's real, right? Let me denote that. A, that's real, and then bi, that's its imaginary part. That's not real. So that's that part, a plus bi, and then that gives us z, right? Well, you can also use sine and cosine. So if you have this angle, right, this angle theta, and then the radius times the cosine of angle theta will give you A here. A equals the radius times the cosine of angle theta. And then B I equals I times the sine of angle theta. That's that part there. The regular sign is just B, and then you have to add the imaginary part. So let's get all of this out of the way. So e to the I theta equals cosine theta plus I times the sine of theta. So if first thing we need to do in order to calculate even what theta is itself, we need to calculate the radius. The radius is the easiest of all. So here we have r, and you know, a squared plus b squared equals c squared. We have x squared plus y squared equals r squared, right? So r equals the square root of p of x squared plus p of y squared. Now p, I just mean position, because again, this is technically, you know, a bit of a physics thing. Let me erase this shit here. I mean crap, you know. P of x squared plus p of y squared. I don't know why Windows keeps fucking talking to me like that, but you know, it's whatever. P of x squared plus p of y squared, that gives us r. Now r is the magnitude of z. So if we have the opposite side, which is IPY, and then the adjacent side, which is p of x, or technically the opposite in terms of just value is p of y, the magnitude of that is p of y. We can put opposite and adjacent, that's TOA. Tangent, yo, fuck, did I type that shit all out for? Delete. We can put theta equals arc tan of the opposite over the adjacent. So that gives us theta. Now theta is also a function of t, because these are functions of t's and they're functions of t and they're changing. So theta is a function of t and r is a function of t. So now we have our equation r e to the I theta equals p, the total position function. Or the total position vector for 2 dimensions given time. Because, you know, the angle is going to change over time. If px gets really, really big and p of y gets small, that angle is going to get small. Right now, the angle's about here. And yeah, that's just a little equation I came up with. Where's my mouse? There it is. Yeah. Hope you guys liked it. Peace out.